Hi there, my name is Alok Pattani, and I'm a data science developer advocate here at Google Cloud. Thank you so much for having me at your conference today to talk about Google Cloud for sports analytics. So Google Cloud, what is it? Well, it's a lot of things and you can use it for many different things, but let's talk about what it means in the context of data science. It's a set of hardware, right? Computers, data centers, these things, and software, tools, products like BigQuery and these that allow you to get insights from data faster. We'll talk about it today in the context of sports, but these tools are useful across many different industries to do data science. Google Cloud has a bunch of sports partners. These are some from the past couple years. We have the NCAA, which is the Association of Colleges in the United States. We have the Golden State Warriors, a really successful basketball organization in the San Francisco Bay Area. We have the MIT Sports Lab, a academic partnership we have with the Massachusetts Institute of Technology. And then down in the bottom right, you'll see the FA, the Football Association in England. And then our newest and one of our most sort of prominent partnerships recently is is a partnership with Major League Baseball. And these are different partners where we can work. You show the value of Google Cloud tools in the context of sports. So today I'm going to talk about a couple different use cases, a couple different Google Cloud products, and how they work with examples from sports analytics. Big picture, what are the things these products can do, and what can Google Cloud help solve in sports analytics? Three different things I can think of. First, it allows you to do the things you do in sports analytics, but do them at scale. So either faster, bigger, or better, right? Then it can make things easier. So you might be able to do the same things you already do, but do it quicker, and therefore, not just quicker, but easily, and therefore be able to think about new ways to apply those same techniques. And then finally, it can enable things that before you might not be able to have done before using new tools and enabling those. So the first topic, let's talk about doing things at scale. So one of the premier data analytics and data science products at Google Cloud is BigQuery, which is Google Cloud's enterprise data warehouse for analytics. It allows queries and storage of up to petabytes of data. And what makes it unique is that it's sort of fully managed and serverless. What that means is you write a SQL query just like you would in other relational databases, but you don't have to specify how many nodes or how many clusters or something you need if that query is going to go over billions or even trillions of rows of data. BigQuery will basically handle everything on the back end, and you can write the same query whether it's for a very small data set or an extremely large one. It also has connections for streaming data, built-in machine learning, which we'll talk about, and an in-memory BI engine, which allows for faster reporting, analysis, dashboards, other things that are super useful in the data science process. So that's kind of the overview of BigQuery, but let's talk about it in a sports example. So the example I've chosen here is NBA, right? Basketball, professional basketball, player tracking data. So for several years now, there have been cameras in each of the NBA arenas tracking the movement of the players and the ball at about 25 times a second. And what that means is you have a huge sample of data. If you look at every player on the court 25 times a second for every game for all of, in this case, we're talking about 6 seasons from 2013-14 to 2018-19. So you can get an idea here in this little table of what it looks like. There's a game, there's a clock, there's a player ID, and just XY coordinates of where on the court that player is. But we have sort of a really big data problem. If you look at the number of rows, that is 7 billion rows of player tracking data. Again, every player multiple times a second. And that's a 1.7 terabyte table. So if you're used to working in a tool like Python or R, it's fairly challenging to deal with this type of data all in one shot. But BigQuery allows you to do these one, use this data, and two, ask questions about this sort of data in a very scalable fashion. So one question I thought might be interesting, not the most interesting NBA question, but one that really illustrates the power of BigQuery, is which pair of players have been closest to each other on the court over all 6 seasons of data? So this requires knowing the distance between any two players and looking across all pairs. So actually here, you're going to even expand your data set from the 7 billion rows to join, right, each player to every other player on the court and calculate distances. So I won't go into this code in detail, but this is basically SQL code that will tell you the answer to this question, assuming you have this data in BigQuery already. And what you can see here is a simple distance formula where we calculate the distance. We do some filtering for making sure the players are on the court for a certain number of minutes over this large span of time. And then we sort by which players are within 5 feet of each other, let's say, for the greatest percentage of time. So there's 2 interesting results here, I think. First is at the top. How long did that query take? So that query processed 672 gigabytes of data, which is a fairly massive amount if you think of terms of sports level data. And it completed in less than 90 seconds. So that's pretty amazing. We went through every single record of our data, right, for 6 years of tracking data. We looked at every player, every other player on the court, measured their distance, calculated whether it was within 5 feet of each other, and took it as a percentage, and then ranked all the player pairs. So that happened in 90 seconds. The basketball answer, and again, if you're a basketball fan, this will be really interesting to you, is that the 2 players who shared the court within 5 feet of each other the greatest percentage of the time were Andre Drummond and Hassan Whiteside. They were within 5 feet of each other 35% of the time, with an average separation of 9 feet. So what you'll also notice here is that a bunch of these pairs involve centers, big guys. So these are players who kind of stay in the paint close to the hoop, kind of on both sides, and then guard each other. So it's not exactly the answer I expected, but if you think about it, it makes a lot of sense. These 2 players don't move around so much on the perimeter like a guard. They'll be close to each other. So we got interesting results, and we got them really fast. Okay, the next topic we'll talk about is making things easier. So one thing that is very common in the data science process is modeling. In some cases, we might be building a complicated machine learning model. In some cases, we'll be doing something like linear regression, logistic regression, some more statistical pieces. And BigQuery ML for machine learning allows you to execute these models in a very simple fashion using SQL. So if you're familiar as a data analyst working with SQL, you might want to use BigQuery ML. Even if you're used to using other tools like R or Python for machine learning, BigQuery ML has the advantage of working right in your database. So you don't have to move millions, maybe billions of rows out of BigQuery into another tool. You can train right there. You can see right now some of the available models we have, linear regression, logistic regression, and others. And it handles a lot of the things that you might have to write custom code for in other places. So learning rate, splitting of training and test data, imputation, one-hot encoding, all these sorts of things are handled behind the scenes in BigQuery ML. And another feature of BigQuery that's really useful for certain things, and I'll get to an example in a minute, is scripting. So what this allows you to do is put together multiple pieces of SQL into a sort of program or script that executes like other scripts do with control and command statements. So you can see the example here, which is just flipping heads or tails and counting them up. But you can declare variables, you can loop, you can have if-else, and then in the end you have some result. It's useful for complicating ETL or ELT, depending on your use case logic, extract, transform, load, and performing tasks that use variables. Maybe you want to calculate something iteratively, these sorts of things. BQ scripting, BigQuery scripting is very useful for this. So an example we'll talk about is from our partnership with the NCAA, going back to the spring of 2020. The NCAA tournaments, which are a very popular event on the sporting calendar, were unfortunately canceled this year due to the pandemic, along with other sports. But this was a very sad time. It happened right when the pandemic was kind of surging in the US. So what can we do? Well, we can use data to maybe simulate March Madness. Not as good, but we don't have it, so let's try our best. So what did we do? We used projected brackets for the tournaments. We were pretty close for who would make those tournaments. It's 68 teams on the men's side, 64 on the women's side. We used BigQuery ML to make a game prediction model using past tournament results, right, to predict what might happen in this year's tournament. And then we have these game predictions, but what we really wanted to calculate was who would advance from one round to the next, and calculate advancement probabilities and simulate entire brackets. So I won't go into it in too much here. I'll show a little example, but what we ended up with was 40,000 different bracket simulations, which we made available in a Data Studio dashboard publicly for fans to play around with. Couldn't have real March Madness, but again, give some example of what it looked like using data. So in this case, we use BigQuery ML, and again, I won't go too much into detail, but it's a pretty simple create or replace model. We pick logistic regression because here we're modeling win percentage, and this is your basic SQL statement, just picking out the data you want. Just from these few lines of code, you both pick the data you want to model and then create your model. You'll get some output here in BigQuery that tells you how accurate you are, precision recall, other common metrics for classification problems, and then you're able to use that model to make predictions. So in the next step here, you'll see, and I've excerpted some of the code, but we use this ML predict statement with the model we just fit, and we create a prediction for every possible matchup in the tournament. So you see here, we're looking at a bunch of matchups involving this team, Kansas. Kansas was one of the best teams in men's basketball going into what would have been the tournament in March of 2020. And you can see when they play certain teams that are not as good, Robert Morris and NC Central, they have a win percentage very high, 96%, 97%. But as the opponents get better, down here we look at Creighton or Duke, who are much better teams, you can see their win percentage is closer to 50-50, 68%, 58%. So this tells us what we want to know about how likely would, in each possible matchup, would each team be of winning. Then we use BigQuery scripting to not only pick the winners, but kind of advance everyone through each round all the way and get a champion. Now, if you do this once, you get a random draw. If you do it 10,000 times, you get a representation of who's likely to advance throughout, and you can do percentages for which are the most likely winners. And we did this for both the men's tournament and the women's tournament. Again, I won't go into the details here, but you can see we have a while loop. We have some sort of Monte Carlo simulations happening in the sims. We set the game round and we advance, and then it's essentially an iterative process that goes through every round of the tournament, and then we store off the data again in BigQuery. And then finally, we made these results available in Data Studio. And Data Studio is a really cool dashboarding and visualization tool, part of the Google package. And what we did here is build these fake sort of brackets. So these were the 64 teams. This is the women's side using one of those mock brackets. And you can see we just track through the advancement. Each time we have the probability of the team advancing here. And in this particular simulation, this is simulation number 1, again of 10,000. We have Oregon winning, going all the way through the Final Four and winning. So again, we're able to simulate the tournament, which is useful in its own right, without actual results this year. All right, so the final topic we'll discuss is how we can use Google Cloud in the context of sports analytics to enable new things that maybe are either really hard or almost impossible to have done before technology like what exists in Google Cloud came around. So some of the really cool things that push the frontiers with Google Cloud are these AutoML and APIs, right? So we have a lot of different products for machine learning type of things that take into different types of data and output different types of results. And in this case, what you're leveraging is Google's sort of excellence in the area of AI and ML and packaging it as a product. So they do a bunch of research, right? Really smart people at Google do a bunch of research in that. What's the best way to extract these entities from video, from pictures, from audio, from text, translation, etc. And then essentially make those things available as products to you. You just call them through an API or through some AutoML type tool within the Google Cloud platform, and you get results. You don't have to worry about making the technology that translates, that picks off into pieces from video. They do this for you. So the two tools I'm going to talk about here are Cloud Video Intelligence and AutoML Vision, again, in the context of a sports example. So in 2019, at the Cloud Next conference in the United Kingdom, again, this was pre-pandemic, so we had fun in-person conferences. A couple of my colleagues put together this demo called Football Peer. So this is football in Europe and most of the world, and soccer in the United States, where I'm based. So excuse the sort of language where we'll go back and forth. But the objective was that participants could come and take a standard soccer penalty kick and try to hit these targets. You'll see in the bottom left, there's these red X's. The goal was to hit one of those two. And you get points for accuracy, how close you are to the X, power, how fast or powerful your kick is, and style. But the only thing that was used to track the data were these 3 Pixel 4 phones. So you have basically your phone camera set up in 3 different areas. One is focused from back on the goal, the other on the side, and the other one on the kicker. And from this, we derived different data that was then usable to find interesting things using Google Cloud tools. So one thing, remember that video of the kicker, is that there's in the Video Intelligence API is a tool called person detection. And what that allows you to do is track every point, I shouldn't say every point, several points on the kicker throughout the process of the kick. So you can see what the person is kicking here, and the data abstracted is at every 10th of a second, where is each of his or her limbs. And the way we do this is a simple call where you have a video, right? So the video comes from the phone, goes into Google Cloud. You point to the video, and then this few short lines of code basically says, yeah, use the video, give me the person detection that I want, and output it. And what you get out is something here that looks like JSON, which tells you a bunch of things, including where was this person's, example, left shoulder, X coordinate, Y coordinate, and some confidence that helps determine if the API feels really good about that location detection or maybe less good about it. So again, with a few short lines of code, we've turned video into data, right? In a traditional data science setup, we're thinking of data as numbers, rows, maybe words, things in a data frame, in a table. This is literally taking a video file and then giving you that data. So that's super interesting, right? But what can we do with this? So then if we go further, right, we take the pose results from the Video Intelligence API, we process them further, put them into BigQuery, do some other BigQuery processing, look across all the videos. I should have said this in the last slide. There's 1,500 different penalty kicks we have tracked data for. And then we try to find unique kicker movements. So in this case, you'll see this is one of the videos that came out of this that was unique. So you can see this player kind of starts with a little shimmy, comes in a sort of looping motion, different from most penalty kicks, and then drives through with like a big push. And this came out not because we looked through the videos to find it, but because the data showed that this one looks a little different, and then we went and referenced the video, and sure enough, it does look kind of different. So you can see here in the context of sports analytics how this might be useful to identify sort of outlier videos or analyze a player's pose, what type of things are going on with them on the field, on the pitch, on the court, on the ice, wherever you might be. And then an additional thing, we use AutoML Vision to track the ball throughout every frame. And then looking at when that ball crossed sort of the plane of the goal, you can create this shot chart. So this is a chart of every kick roughly that took place in this competition. You can see a lot of people were fairly accurate. Both these X's got a lot of balls near them. And then a lot of people were a little less accurate. So we can see a full shot chart. In this case, this was part of a notebook that was released to each of the participants, and then you could put in your ID and find your 3 kicks. So this is where one person's 3 kicks were on this shot chart. So again, we're taking a video of a ball and a kicker, and we're creating true sort of sports analytics insights, like a shot chart that you might get for like a professional player, but this is, again, just using 3 Pixel 4 cameras at a demo. All right, so let's wrap up here. Google Cloud, right? So we said it powers analytics, and in this case, we'll say sports analytics, but this is true for kind of all analytics, right? And what are the things we talked about? So scaling things up, making them, work with bigger data and faster, making things easier, right? That's our easy button. And then doing things we couldn't do before, creating new things. That's where you see the create all the things. So that's kind of the big picture of how Google Cloud works with sports analytics. But again, this is true for all things. And hopefully this gives you some ideas of the way cloud-based computing and tools can really take the next, help take the next leap forward in sports analytics. Thank you again for having me at your conference. You can find me at Twitter at Alok Pattani or email me at alokpattani@google.com. And I really appreciate you having me speak. Thanks again.